Wherever you are tonight, maybe resting beside a window lying under the quiet hum of the city, or wrapped in darkness beneath the open sky, take a slow breath and let everything soften. Above you, the universe continues its endless motion. Stars are being born, light is crossing unimaginable distances, and time itself drifts like a tide. Every breath you take tonight carries the memory of stars long gone, their dust now part of you. As you listen, let that thought bring you peace. You are connected to everything that has ever been. Before we begin our journey, tell us in the comments, where are you watching from? Tonight, are you under clouds, city lights, or a sky full of stars? We love knowing where the universe meets you. So settle in, breathe deeply, and let your mind drift outward into the quiet where galaxies turn and the night unfolds, its science and its dreams. In the beginning, the universe was filled with light and yet cloaked in opacity. The early cosmos was a dense, glowing sea of charged particles, protons, electrons, and photons, all intermingled in a hot plasma. In that primal epoch, any photon, a particle of light that attempted to travel, would almost immediately scatter off a free electron, bouncing and rebounding like a ball in a foggy hall. The result was a universe of radiant thunder and electric blur, where light could not escape the dense crowd of matter. As the universe expanded, it cooled. Gradually, it approached a pivotal moment: recombination. The stage when the ambient temperature dropped low enough for electrons and protons to combine and form neutral hydrogen atoms. This transition unfolded roughly 370,000 years after the Big Bang. Once electrons settled into atomic orbit, photons no longer scattered nearly as often. The fog lifted, the cosmos became transparent. Light could finally embark on long journeys. This ancient glow, freed at that moment, still fills all of space, the cosmic microwave background, or CMB. At the time of recombination, the universe's temperature was about 3,000 kelvins, warm, glowing, roughly similar to the light from cooler giant stars. But over billions of years, as space itself stretched, that light was redshifted, its wavelengths lengthened, cooling, until now its spectrum corresponds to about 2.7 kelvins, barely above absolute zero. That whisper of radiation, 8 to 9 billion times longer in wavelength than its original glow, is the CMB we measure today. It is remarkably uniform, nearly the same in every direction, with temperature variations of mere 100 microkelvin. As the listener exhales into calm picture, the first light weaving through a clearing, the universe was no longer a blur of scattering charges, but a stage upon which light could wander freely. This moment is often called the surface of last scattering, the moment when photons last collided with free electrons in any significant way before drifting onward. In that glow lie slight ripples, small fluctuations in temperature and density. These fluctuations, frozen into the fabric of the CMB, are the seeds of cosmic structure. Regions ever so slightly denser or hotter would later gather matter by gravity, becoming galaxies and clusters. Another subtle process had its hand here: diffusion damping, sometimes called silk damping. Photons, before decoupling, could drift from hotter zones toward cooler ones, smoothing out tiny irregularities. On the smallest scales, differences faded. The result is a smoother cosmic canvas, but one that still retains broad strokes of variation. The more I reflect on this, the more the ancient glow feels like a photograph of a delicate dawn, softly lit, anticipatory, infinite in its quiet reach. The CMB is not just remnant light. It is a messenger from a time when the universe first learned to let light roam. Today, scientists observe this background in exquisite detail. Satellites like COBE, WMAP, and Planck have mapped its variations at microkelvin precision, confirming the standard cosmological model of the Big Bang and inflation. The overall blackbody shape of the CMB's spectrum is among the most precise pieces of cosmological evidence, remarkably close to a perfect blackbody curve. Tiny departures from this shape, known as spectral distortions, are actively studied as to windows into early universe physics. For example, recombination, line emissions of hydrogen and helium that subtly perturb the spectrum. Let the mind drift to a cosmic pond. At first, ripples churn violently, but as the water cools and stills, gentle wavelets remain the imprint of what came before. The CMB is much like that, a cooled, tranquil echo of primordial turbulence now whispering across the void. In the haze, before recombination, light could not travel far. But once that boundary was crossed, photons embarked on journeys across time. The CMB gives us a snapshot of the universe at that critical moment. In effect, we see the cosmos as it was when it first allowed us to see. From our vantage, those photons have traveled billions of light years. They've stretched, reddened, cooled, and yet they still carry the imprint of that first light. In that sense, every direction we look is toward a boundary in time, toward the moment the universe became transparent. We can even sense the slight deviations, cold spots and warm spots, density, imbalances, fingerprints of sound waves traveling through the primordial plasma, gravitational redshifts, Doppler shifts, all encoded in that ancient glow. Reflect you are bathed in light that left its source when the universe was only a few 100,000 years old. The same photons that escaped then now float through your body around your world, a cosmic whisper, millions of times cooled, but still luminous. As the sunlight outside dims tonight, know you are cradled by the first light the cosmos ever liberated. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. In the wide darkness between the stars, there are worlds that drift alone. No sunrise touches their surfaces. No parent star warms their skies. They are called rogue planets, wanderers untethered from any solar system, set adrift in the quiet sea of space. Astronomers first suspected their existence while watching the subtle dimming of distant starlight. Some flickers came not from orbiting planets, but from invisible masses that briefly bent light through gravitational microlensing, a gentle magnifying effect predicted by Einstein's theory of relativity. Through these delicate measurements, we learned that space is full of orphans, planets that roam freely unseen, by most telescopes, revealed only when they pass in front of something brighter. It is estimated that in our galaxy alone, there could be billions of these drifters, perhaps more of them than stars themselves. Some may be as small as Mars, others as large as Jupiter. Many formed normally around young stars, but were ejected after gravitational skirmishes in their early solar neighborhoods. Others may have been born alone, condensed from collapsing clouds too small to ignite nuclear fire. Imagine one of these worlds, a silent globe wandering through blackness. The nearest star might be trillions of miles away its light, a mere hint too faint to cast a shadow. The planet's surface lies beneath an endless night sky, where constellations do not rise or set. Yet even here, nature persists. Some rogue planets may hold internal heat left over from their formation, radioactive elements in their cores, still releasing energy after billions of years. A few might even host thick atmospheres of hydrogen or methane, trapping this warmth beneath layers of pressure. In such buried oceans far beneath the frozen crust, chemical reactions could still occur, slow, steady, and unseen. We often imagine life requiring sunlight, but perhaps warmth alone, deep, geothermal, and patient, is enough. In the cold heart of interstellar space, there might exist worlds with secret seas quietly circulating, never knowing the light of a Sunday. It is a humbling thought. Even in total darkness, the story of chemistry and change does not end. In a sense, these planets are reminders that the universe allows life and matter to adapt endlessly to circumstance. To understand them, scientists build detailed models of planetary heat retention and atmospheric collapse. If a massive rogue planet retains a dense hydrogen blanket, the gas acts like insulation, preventing the last of its heat from radiating away. Some studies suggest that beneath such thick skies, the surface could remain near room temperature, warm enough for liquid water to exist, even without starlight. Picture that for a moment an ocean beneath darkness, waves moving slowly in silence, illuminated only by the faint glow of geothermal vents. There would be no sunrise, no seasons, only timeless twilight and the quiet pulse of planetary breathing. And yet these planets are not lost. They are part of a larger pattern, the cosmic dance of gravity, motion, and release. Every star, every planet, every moon carries the potential to drift away one day. Orbits change, tides shift, galaxies collide. Over billions of years, even the most stable systems can loosen their bonds. What was once home becomes journey. Perhaps in that sense, these rogue worlds are not tragic, but free travelers in the deepest wilderness, unobserved, but never outside the grand rhythm of the universe. They move through vast, faintly glowing corridors of interstellar dust, sometimes brushing past nebulae where other stars are being born. Their surfaces might briefly feel the warmth of a passing sun before falling again into cold. Some may be captured once more, drawn into the gravity of a newborn star, beginning a new chapter. This endless cycle, capture, orbit, release, and drift, is part of what keeps the cosmos alive with movement. Nothing is ever completely still, and even in the darkest corners, energy finds expression. There is a kind of poetry in imagining these orphaned planets as quiet witnesses. They pass silently by galaxies through spiral arms and cosmic filaments, bearing no light of their own, but carrying the history of a million suns. From a scientific view, they are evidence of the violent youth of planetary systems, collisions, close encounters, and gravitational chaos. But from a human view, they remind us of endurance, that existence continues even when the familiar light is gone. If one could stand upon such a world, what would the sky look like? The Milky Way would still appear as a soft river of pale light, perhaps brighter, without a nearby sun to wash it away. Stars would crowd the heavens sharp and brilliant. Each would seem a destination, a possible home, though all infinitely distant. The ground beneath your feet would be frozen iron and stone, but beneath that warmth, pressure, and chemistry, that warmth is the faint heartbeat of creation, echoing still. In the quiet of such imagination, something stirs in us too, a reflection of our own smallness and resilience. We too drift through the galaxy, aboard a single world, warmed by our star, but surrounded by vast, dark distance. Our home is in essence a lucky wanderer that found its place in orbit, not adrift, but still moving through endless night. Astronomers continue to search for rogue planets with new instruments, infrared telescopes, space observatories, and microlensing surveys that scan millions of stars for fleeting lensing flashes. Each detection is a whisper of another unseen world, proof that the galaxy is full of hidden travelers. Some of these searches may even one day detect signs of complex chemistry, perhaps spectral hints of water, vapor, ammonia, or methane in the faint light, reflected from these dark worlds. That will not make them less lonely, but it will make them more known, and in knowing them we expand our sense of what the word world can mean. We live in a universe that wastes nothing. Even isolation has purpose. Every drifting planet is a piece of the cosmic mosaic, a thread in a larger invisible tapestry of motion and balance. And so as you listen to this story, imagine these wandering spheres gliding quietly through the void, slow, patient, ancient. They do not glow yet, they move in grace. They do not shine, yet they endure. Every one of them is a silent promise that even in the darkest places, creation still hums softly, waiting to be seen. And now, as we leave these quiet travelers to their endless night, we look forward toward the next mystery, the heartbeat of time itself, breathing in and out across eternity. And as these lonely worlds drift on far beyond our reach, the cosmos continues its rhythm, expanding, contracting, resting, and awakening again. In the endless breath of creation, we begin to wonder, does time itself have a pulse? Time is the silent rhythm that holds the universe together. It stretches between galaxies like an invisible current, flowing through the ages with a patience beyond measure. And yet even this flow, so steady, so certain, may not be constant. Some cosmologists whisper that time too might breathe. When we look across the stars, we are not only looking outward, but backward. Every ray of light we see carries an echo from the past. The farther we gaze, the younger the universe becomes a living time machine where billions of years unfold in reverse. But if we could somehow step outside that river and see all of time laid bare, we might find that the current itself is not one way. There are theories built from mathematics and imagination that suggest the universe is cyclic, that after expanding for trillions of years, space may slow pause and contract again, only to be born anew. It is an idea called the Big Bounce. In this view, the Big Bang was not a singular beginning, but one heartbeat in an eternal cycle, expansion and collapse, inhale and exhale forever. The notion is ancient, as well as modern. Long before telescopes, philosophers in India and Greece imagined worlds that rose and fell in infinite repetition, each age folding into the next, like waves returning to shore. Today, physics gives this poetry a structure of its own. A cosmos where quantum fields and dark energy might someday reverse their signs, pulling everything inward again. For now, observations suggest the opposite: the universe's expansion is accelerating, driven by dark energy. But if that mysterious pressure changes over unimaginable time, spans the tide could turn. The galaxies that rush away might one day drift back toward reunion. Stars would brighten in their final blaze as gravity drew them inward, and space itself would tighten until energy, matter, and light once more merged into unity. And then perhaps a new universe would bloom. It is a hauntingly beautiful thought that every ending is the prelude to another dawn, that the darkness we fear may only be a moment between breaths. Even if the cosmos does not collapse and begin again, time still dances in strange ways. In the vast reaches of relativity, time is not uniform. It bends and stretches with gravity. Near a massive star or black hole, clocks tick more slowly than in open space. A minute on the surface of a neutron star could be an hour for someone far away. Einstein showed us that time and space are woven together, one fabric of motion and geometry. When mass or energy is present, that fabric curves, and when it curves, time itself warps slow in deep valleys of gravity, quick along open plains of emptiness. So even now, while you rest beneath Earth's sky, Time is moving differently for you than for the stars above. The seconds you live and the seconds they live are not quite the same, though both feel equally real. On a cosmic scale, this means there is no single universal now. Every observer carries their own present, shaped by their motion and their place in gravity's field. And yet the universe remains coherent. Like an orchestra in which each instrument follows its own rhythm, the whole still moves together in harmony. The laws of physics are astonishingly consistent. From the smallest atom to the largest galaxy, the equations that govern energy and motion appear timeless. But what of time's direction itself? Why does it seem to flow forward from past to future and never back? Scientists trace this arrow of time to entropy, the tendency of systems to move from order toward disorder. In the beginning, the universe was remarkably uniform, smooth, low in entropy. As it expanded, structure emerged stars, planets, galaxies. Yet overall entropy increased. It is this increase, this gradual spreading and blending, that gives time its sense of direction. A broken cup does not reassemble. A burned star does not reignite. In every process, energy spreads, patterns diffuse, and complexity gives way to balance. This universal drift toward equilibrium is not destruction. It is evolution, a deep, patient settling into simplicity. The same principle that makes stars burn also makes memories fade and winds calm. Entropy is, in a way, the soft heartbeat of time, the slow exhalation that will one day bring even galaxies to rest. But time, though often imagined as a straight line, might instead be a curve that folds back upon itself. Some theories of quantum gravity suggest that on the smallest scales, time may blur, flicker, or loop. In those hidden dimensions beneath Planck length, the universe may not distinguish before from after. There, everything might simply be timeless, motionless, infinite potential. If this is true, then time as we know it is a large-scale illusion, a rhythm that emerges from deeper stillness. Like waves on the surface of a boundless ocean, time ripples across the quiet depths of something more fundamental. Think of breathing. The inhale brings expansion, the exhale calm. Both are part of the same life. The universe may do the same, not in seconds or years, but in epochs so vast they defy comprehension. Each cycle, each breath, may give birth to new stars, new matter, new chances for awareness to rise and look back in wonder. Even in our own daily lives, we sense this breathing of time, the pulse of a second hand, the rhythm of the tides, the widening and shrinking of a heartbeat. Everywhere nature echoes the same cadence: expansion and rest, growth and release. Perhaps it is not time that passes, but we who drift through it, carried along like leaves in a gentle current. Perhaps the past and future are not distant shores, but reflections on the same vast surface. Theoretical physicists, searching for a complete picture of the cosmos, a union of relativity and quantum mechanics, sometimes describe the universe as timeless at its core. Equations like the Wheeler-DeWitt formulation do not include a variable for time at all. Instead, time appears as an emergent property, a perception born when matter and energy interact in complex ways. That means that the ticking of clocks, the decay of atoms, the beating of hearts, all are patterns, localized flows of change within something that in total does not change. The eternal now. It is difficult to imagine, and yet deeply peaceful. For if the universe at its deepest level is timeless, then nothing truly vanishes. Every moment, every photon, every breath still exists somewhere along the fabric of being like notes, suspended forever in a cosmic song. And so, as the universe expands outward, we may imagine it also inhaling inward, drawing in memory, energy, and experience toward its core. The balance between those motions, invisible yet constant, keeps the cosmos alive. In that rhythm, stars are born. Galaxies spiral. Planets drift. Life arises, and awareness, fragile, luminous awareness, looks up and names the pattern it feels. Time. Let that realization settle for a moment. You are part of this breathing. Each heartbeat, each breath you take, echoes the motion of galaxies expanding and contracting across the ages. You are quite literally the rhythm of the cosmos made conscious. And as we continue our journey, we follow that breath outward again toward the light that carries the past to us. As the universe exhales, its light travels outward, stretched, softened, and ancient. To look into that light is to look backward through billions of years to see time itself painted across the stars. In the next chapter, we learn how our eyes and our instruments can see through time. Light is the oldest storyteller. Every beam that reaches us carries a tale from long ago, a whisper of how things once were. When you look at the night sky, you are never seeing the present. You are seeing memory traveling at the speed of light. The light from the moon takes just over 1 second to reach Earth. From the sun, about 8 minutes. The nearest star, Proxima Centauri, shines from more than 4 years away. And when we look at the most distant galaxies, their light has been traveling for over 13 billion years, almost the entire lifetime of the universe. To gaze into the night sky is to look back in time. The farther our telescopes peer, the younger the cosmos becomes, until we reach that early age when galaxies were first gathering, when the first stars ignited and the cosmic fog began to clear. This ability to see through time is one of the quiet miracles of astronomy. Unlike explorers who travel across oceans or mountains, astronomers travel through light, following its faint traces, backward decoding, its patterns learning the story of creation written in invisible waves. Light does more than illuminate. It stretches, bends, and carries the fingerprints of the journey it has taken. As the universe expands, it stretches the very waves of light themselves. This is called cosmological redshift, the lengthening of light's wavelength as space itself grows. The greater the redshift, the longer the light has traveled, and the older the story it tells. Through redshift, we can measure distance and age, turning the night sky into a timeline of the cosmos. When astronomers observe a galaxy whose light is shifted deeply into the infrared, they know they are seeing it. Not as it is today, but as it once was, perhaps only a few 100 million years after the Big Bang. To study such faint ancient light requires instruments of extraordinary sensitivity. The Hubble Space Telescope gave us the first deep glimpses, fields of darkness, where long exposures revealed thousands of galaxies hiding in what once looked empty. It was like opening a window in the black and finding a universe teeming with stars. And now a new eye has opened wider still, the James Webb Space Telescope. Webb is tuned to the infrared, a range of light stretched by time and expansion. This allows it to see the earliest galaxies, those whose light has been traveling for more than 13 billion years, now dimmed and reddened by the long journey. When Webb peers into that distance, it is not simply seeing far away, it is seeing far back. Every faint spark it captures is a young galaxy, its stars still forming its dust, still glowing from heat. Some of these galaxies may have existed only briefly, merging or fading long before our sun was born. Yet their light still travels, arriving only now across oceans of space-time. In a single image, we see history frozen, in motion, the universe, as it was when it first began to shine. Consider how strange this truly is, when Webb looks at the most distant cluster it might be. Seeing light that set out when space was less than 1/10 its current size. That means the photons reaching Webb's mirrors have been traveling for nearly the whole age, of everything crossing billions of light years that have stretched behind them as they moved. To see these galaxies is to see the dawn. They appear small and bright, like scattered embers, still glowing in the cosmic night. And in their arrangement, the way they cluster, stretch, and merge, astronomers can trace the growth of structure from that early time to now. Light then becomes both messenger and map. By studying its color and brightness, we learn how quickly the universe expanded at different eras. By measuring how much light bends as it passes massive clusters, we learn the distribution of invisible matter shaping the cosmos. Every photon, every faint pulse, contains coordinates in time and gravity. Even our own sun participates in this endless exchange. Its light, though close, still travels 8 minutes of emptiness before touching your face or warming your skin. The warmth you feel is ancient. By the time it reaches you, its atoms born in a cloud, long vanished. This is the great paradox of light. It moves at the ultimate speed, yet it is always late. Every glance into the sky is an act of time travel. Some stars we see tonight no longer exist. Their light began its journey before humans ever walked, the earth before the continents, settled before oceans had names. Their photons, relentless and tireless, cross the eons, arriving now, completing a story that began before our world was even formed. When we realize this, the night sky changes. It is no longer a still dome of distant points, but a moving archive, a living record of what was. Each color, each shimmer, tells a different chapter of cosmic history. Astronomers read that light as if it were language. The spectrum of a star, its rainbow stretched and scattered, reveals its temperature, composition, motion, and age. Every dark line in that spectrum is an absence, a note where certain wavelengths have been absorbed by specific elements. These gaps are signatures, evidence of hydrogen, helium, carbon, iron, and more. From those patterns, we know what stars are made of, how they burn, and when they were born. It is through such patient reading that we discovered the expansion of the universe itself. When Edwin Hubble observed that distant galaxies all showed redshift, all moving away, he realized that space was not static but stretching. It was as if the universe itself were breathing outward, carrying everything with it. This discovery transformed our understanding of reality. Time and distance became intertwined. Every star, every photon part of one grand, unfolding story. The more we look, the farther back we see, and the more we realize how interconnected all things are. The light of the first stars forged the heavy elements that later formed planets, oceans, and eventually us. In that sense, the light that left those first galaxies, billions of years ago, was already destined to return here, to be seen, to be understood. There is something deeply moving in that realization that the universe is not silent but constantly speaking through light. Every sunrise, every reflection on water, every glimmer in the eye, is part of that same communication spanning from the dawn of time to now. And so, when you look up, know this: the light that enters your eyes has traveled through the ages, carrying the history of creation. It has crossed darkness and gravity and expansion to find you. You are, in this moment, the end point of its journey, the witness for which it has waited since the beginning. Close your eyes for a breath and feel the faint warmth of that connection. You are surrounded by light that has been traveling toward you for billions of years. You are yourself an instrument of its seeing, and as we turn from that light, we begin to sense what holds it, the invisible lattice that shapes where galaxies form, the hidden web that guides their motion. The next story lies there beyond sight, yet present in every shimmer, the silent gravity that sculpts the cosmos. And so as light reveals what once was, we begin to wonder about what cannot be seen, the unseen structure beneath the stars, the quiet architecture of gravity itself. In the next chapter, we travel into the invisible, the hidden web. Beneath the glowing tapestry of galaxies lies a structure we cannot see. It stretches farther than any telescope can reach, more intricate than any constellation we could draw. Astronomers call it the cosmic web, an immense invisible framework of matter and gravity upon which the entire universe is built. At first glance, the night sky looks scattered and random galaxies sprinkled across infinite space. But when scientists map their positions in 3 dimensions, a breathtaking pattern emerges. Galaxies are not evenly spread, but woven together like threads of lace. They cluster along filaments that span hundreds of millions of light years, connecting at bright knots where galaxy clusters gather. Between them lie enormous voids, vast silent regions, almost empty of galaxies, each spanning hundreds of millions of light years across. This pattern, filaments, clusters, and voids, is the architecture of the universe itself. And yet the material that makes it visible, the stars, planets, and gas, accounts for less than 5% of all that exists. The rest is hidden. The majority of the universe's mass is made not of atoms, but of something invisible, dark matter. It does not glow, reflect, or absorb light. We cannot see it, but we can feel its pull. It acts as scaffolding, shaping the distribution of galaxies and dictating how cosmic structures grow. Dark matter reveals itself only through gravity. By studying the motion of stars within galaxies, astronomers noticed something strange. The stars at the edges move far too quickly to be held by visible matter alone. There must be additional mass unseen surrounding and binding the galaxy together. This invisible halo of matter extends well beyond each galaxy's shining edge, forming the gravitational backbone of cosmic structure. Without it, the Milky Way would fly apart like dust on the wind. When cosmologists simulate the universe in computers, starting from the faint ripples in the cosmic microwave background, dark matter plays the starring role. It collapses, first pulled inward by its own gravity, forming a web-like network of dense nodes and filaments. Ordinary matter, the kind that forms stars and planets, follows this hidden structure, gathering along the same lines, lighting up the framework, like frost tracing a spider's thread. It is as if the visible universe is the luminous outline of something much larger and unseen, a glowing mist caught in a net of gravity. The cosmic web is not a metaphor, but a measurable structure. Astronomers can trace it by mapping the light from millions of galaxies, or by detecting the faint absorption lines their light creates as it passes through diffuse hydrogen gas. These maps show that galaxies tend to form chains and walls surrounding the enormous empty spaces of intergalactic voids. If you could drift outside our galaxy and look upon this structure as a whole, you would see something both delicate and vast, a glowing, interconnected web stretching across the cosmos. Filaments of galaxies thread together like rivers of starlight, converging on clusters that shine like jeweled knots. In that grand web, the Milky Way is a single point, a small pearl on a thread of light, moving slowly within the vast gravitational network. The dark matter that shapes this pattern is thought to make up about 85% of the total matter in the universe. Its nature remains one of science's greatest mysteries. It is not made of the same particles as normal matter. It does not interact with light, nor with the electromagnetic forces that shape atoms. But it does respond to gravity, and so it forms halos and bridges where visible matter later collects. To study it, astronomers use a remarkable effect known as gravitational lensing, the bending of light as it passes massive objects. When light from distant galaxies travels through regions rich in dark matter, its path curves slightly, distorting the image we see. By measuring these distortions, these subtle ghostly warps in starlight, we can map where dark matter lies. In those lensing maps, the web emerges once again, unseen yet undeniable. Filaments and halos glow, not with light, but with influence, an invisible skeleton, revealed by the bending of distant light. It is humbling to realize that we live in a universe where most of what exists cannot be seen directly. All that we can touch, every planet, every star, every atom of our bodies, is only a faint trace upon the deeper structure of reality. And yet, this hidden matter is what allows beauty to exist at all. Without it, there would be no galaxies, no stars, no gravity strong enough to form planets or sustain the delicate cycles of creation. Dark matter gives the universe its shape, its balance, its rhythm. Imagine drifting through one of those great cosmic filaments. You would see clusters of galaxies, glimmering like lanterns, connected by faint bridges of gas and gravity. The spaces between them would be vast, tens of millions of light years wide, yet still bound by the same silent thread. The light of each galaxy would take millions of years to reach its neighbor, and yet, in the language of gravity, they are speaking constantly bound in a slow, graceful conversation of attraction and release. Between these glowing chains lie the cosmic voids, immense regions, almost entirely empty. They are the quietest places in existence. Temperatures hover near absolute zero. Galaxies are rare, and the nearest star might be hundreds of millions of light years away. And still, even there, gravity hums softly, holding the balance of expansion and rest. The cosmic web continues to evolve. Over billions of years, matter flows along its filaments like rivers of dust and gas, feeding the clusters that grow brighter at the intersections. These clusters, like cosmic cities, become homes to thousands of galaxies, all orbiting within the deep wells of dark matter. One of these great clusters, the Virgo cluster, anchors our own local group of galaxies. The Milky Way, Andromeda, and dozens of smaller companions are being slowly drawn toward it, pulled by gravity along one of the web's filaments. In hundreds of billions of years, these clusters may merge, forming even larger structures, superclusters beyond imagination, until gravity itself can no longer overcome the accelerating expansion of space. When viewed in this way, the cosmic web becomes a living structure, a vast breathing organism whose filaments are the veins of the cosmos, pulsing with the slow rhythm of time. Every galaxy, every cluster, every faint glimmer of light follows that unseen pulse. If the early chapters of our story were about light, its birth, its travel, its whispers of the past, then this chapter is about the stage upon which that light performs, the dark scaffolding that gives meaning to brightness. Light may tell the story, but dark matter gives it shape. And when we finally glimpse that invisible framework, we begin to understand that even emptiness is structured, that even the unseen is alive with design. The universe at every scale reflects the same balanced chaos woven into pattern randomness, forming order silence, giving rise to harmony. It is the hidden web that connects all things: galaxies, stars, planets, and perhaps even thought itself. We are woven into it too. Our bodies made of ancient stardust exist because of the gravity sculpted by dark matter. The iron in our blood, the oxygen we breathe, all condensed along filaments that reach back to the dawn of time. In this way, the invisible becomes intimate. The web that stretches across billions of light years also holds us quietly in place. And as we drift along this cosmic lattice, following the lines of unseen gravity, we approach the next great mystery, where light itself begins to curve and reveal the invisible through its own bending. Beyond this web, where gravity grows denser and the threads of matter twist upon themselves, light begins to bend and loop in perfect arcs, illusions drawn by mass and time. In the next chapter, we'll follow those curves into the artistry of gravity itself. Gravity is the universe's quiet artist. It paints not with color, but with motion. It shapes not with brushes, but with curves. Through its invisible hand, light itself becomes sculpted, stretched, bent, and folded into patterns of astonishing beauty. When light from a distant galaxy travels toward us, it follows the geometry of space-time, that vast, pliable fabric described by Einstein's theory of general relativity. If a massive object, a star, a cluster, or a dark matter halo lies along the way, the light does not move in a straight line. Instead, it curves following the contours of gravity's well. To an observer, that bending of light becomes an illusion, a gravitational lens. The background galaxy may appear distorted, magnified, or multiplied, as if seen through a cosmic magnifying glass. Sometimes, the effect creates perfect rings of light, known as Einstein rings, when source lens and observer align in exquisite precision. At other times, the image splits into mirrored arcs or delicate streaks that stretch around the gravitational mass. These arcs are not tricks of the eye. They are portraits of space-time itself. They reveal the shape of the unseen, where mass lies hidden, how it curves the path of light, and how gravity itself sculpts the stage of the cosmos. Astronomers use these natural lenses as tools. A massive galaxy cluster, rich in dark matter, acts like an enormous telescope, amplifying the light from galaxies far behind it. Through such cosmic lenses, we have glimpsed galaxies so distant that their light began its journey when the universe was less than 1 billion years old. It is poetic to think that gravity, which binds and bends, also reveals that its pull gives us sight into realms we could never otherwise reach. A force of attraction becomes a force of illumination. Even starlight, when passing near a massive body like our Sun, bends slightly, a shift so small it was only confirmed during the solar eclipse of 1919. In that moment, Einstein's wild idea that gravity is not a force in the ordinary sense, but the curvature of space-time itself, was proven correct. Light that most steadfast traveler could be persuaded to change its course following the graceful arcs of warped geometry. Since then, gravitational lensing has become a window into the invisible universe. Weak lensing, subtle distortions spread across the sky, helps astronomers map the distribution of dark matter on the largest scales. Strong lensing, the dramatic arcs and rings, reveals the densest concentrations of mass where gravity reigns supreme. Each of these cosmic canvases tells a story. In some, a single quasar. A brilliant ancient beacon is seen as 4 identical images arranged in a cross, each one a different path, taken by the same light, around the same massive lens. In others, Vast arcs curve like ribbons of fire around a glowing cluster, echoing the shapes of galaxies behind them. What we see is not just light, but time itself stretched and delayed. Because the paths are different lengths, the light from each image reaches us at different moments. A single distant event, a stellar explosion, or flickering quasar can appear multiple times, separated by days, months, or even years. In those repeated flashes, we glimpse time folded upon itself. It is as if the universe were showing us the same scene from several angles, allowing us to study the same moment again and again. Through this, astronomers measure the expansion of the cosmos, the growth of structure, and even refine our understanding of dark energy, that mysterious pressure pushing space apart. But beyond the data and precision lies something more deeply human, the beauty of realization. To see gravity bend light is to watch the cosmos draw, in its own language, arcs and rings of illumination traced by invisible hands. Every lens is a masterpiece, each one a spontaneous artwork, made not by chance, but by the steady logic of physics and the grace of geometry. Imagine drifting through space near one of these lenses. From your vantage, the background galaxies would appear doubled and curved, their light flowing around the gravitational mass, like silk around a stone in a river. The cluster itself would glow with 1,000 suns wrapped in faint halos of dark matter whose presence you cannot see, but can feel through their effect on light. In that slow ballet of bending light, the universe expresses both power and tenderness. Power in the way mass shapes all paths within its reach. Tenderness in the way those distortions create beauty patterns of symmetry and reflection, soft arcs that resemble halos and ripples. The mathematics of lensing are elegant. Gravity does not pull on light. Directly it alters the stage upon which light moves. Space-time curves around mass, and light follows those curves, always taking the shortest possible path through that warped terrain. Thus, the photon, weightless and free, still obeys gravity's will, not because it feels the pull, but because the space it travels through is itself bent. In this, there is a quiet lesson. Even the freest things in the universe must still follow the shape of reality. Freedom and structure are not opposites. They coexist, each giving meaning to the other. Gravitational lensing also teaches us humility. It reminds us that we do not see the universe as it truly is, but as light allows us to see. Every image we capture is filtered through space-time's gentle distortions, through cosmic mirages older than our planet itself. Our telescopes collect these echoes and assemble them into meaning. But the universe has been painting such patterns since long before any eyes were there to behold them. In the coming centuries, astronomers will use space observatories far beyond Earth's orbit to study these lenses in greater detail. They will map dark matter more precisely, measure how light shifts with expansion, and perhaps glimpse new forms of matter entirely. But no matter how sharp our instruments become, the wonder will remain, light shaped by gravity speaking in curves and arcs, teaching us to see beyond the visible. It is remarkable that what was once a symbol of limitation, gravity, the force that holds us down, has become the very means by which we see farther than ever before. The same principle that keeps our feet on the ground allows our minds to travel across billions of years. In this harmony of forces, attraction and revelation, the universe becomes an artist of unimaginable patience. It does not rush. It waits, stretching light over epochs, arranging its scenes in silence, knowing that one day a curious mind will look up and understand. And when we do, we find that the cosmos is not merely a collection of things, but a living gallery of patterns, some bright, some hidden, all shaped by the same graceful hand. Let the image linger light, arcing like golden ribbons across the deep, curving around clusters that gleam in the dark. The universe, through gravity's art, reveals its structure not only to our instruments, but to our imagination. And just beyond those luminous curves lie the engines that power them, objects of such density that light itself cannot escape. They are the final expressions of gravity's strength and the next chapter of its artistry. Beyond the arcs and rings where gravity deepens to its greatest intensity, lie the stars that have collapsed under their own weight, spinning magnetic and bright as cosmic lighthouses. In the next chapter, we listen to their rhythm, the clocks and storms of heaven. In the deep quiet, after the curves of gravity, the universe begins to hum with rhythm instead of light. Out among the ashes of massive stars, there are remnants that beat with flawless precision. These are pulsars, the spinning cores left behind after a supernova's final flash. Each one rotates hundreds of times each second, releasing beams of radiation that sweep through space like celestial lighthouses. When that beam passes Earth, we receive a pulse, a heartbeat from the edge of eternity. Each pulse arrives with astonishing accuracy, a cosmic metronome, more precise than the finest atomic clocks on Earth. Some pulsars lose less than a millionth of a second over many years, spinning steadily, despite the storms of magnetism that rage within them. They are the universe's timekeepers, marking the flow of cosmic history with unwavering consistency. From their steady rhythms, astronomers can detect the subtle stretching of space-time caused by gravitational waves passing between them. Even in death, these stars speak their light silent, but their timing exact. A pulsar's density defies imagination. It is no larger than a city, yet holds more mass than the Sunday. Within its core, matter is squeezed until protons and electrons merge into neutrons, creating a single vast atomic nucleus. A spoonful of such material would weigh billions of tons more than every mountain on Earth combined. The surface gravity is so intense that falling just 1 inch would be like plummeting thousands of miles in a single instant. Surrounding many pulsars are storms of magnetism beyond all earthly experience. These are magnetars, neutron stars, with magnetic fields trillions of times stronger than Earth's. In a magnetar's presence, atoms themselves are stretched and torn apart. When these fields twist and snap, they release bursts of energy, so powerful they can outshine an entire galaxy for a brief moment. Yet from far away, we feel only a flicker, a faint ripple of their silent fury crossing the vacuum. And still, despite such power, these stars endure with calm regularity. Their pulses cut through the darkness like steady breaths, constant and precise. In their timing, astronomers find order amid cosmic violence. By tracking these pulses over decades, scientists can measure how neutron stars slow down, lose energy, and cool, offering clues to the physics of matter at densities that can never be recreated on Earth. Each pulse is a note in the symphony of the universe's evolution. Sometimes when a pulsar orbits a companion star, their interactions grow even more dramatic. The pulsar's gravity can pull gas from its neighbor, creating glowing disks of infalling matter that heat to millions of degrees. As the gas spirals inward, it releases X-rays that flash rhythmically with the star's spin. To distant observers, these binary systems become cosmic beacons, signals of both destruction and balance, where energy and gravity coexist in perfect rhythm. There are even millisecond pulsars whirling hundreds of times per second. They have been spun up by the transfer of material from companion stars, gaining angular momentum until they rotate faster than the blades of a turbine. Their pulses arrive so predictably that entire networks of them, called pulsar timing arrays, are now used to detect the faint, long waves of gravity produced by merging black holes, billions of light-years away. Through these tiny flickers, the universe reveals its grandest motions. If we could stand upon the surface of such a star, we would see a world of pure extremes. The sky would curve under the crushing pull of gravity, and the horizon would wrap around us in a narrow circle. The magnetic fields would twist the very air into streams of plasma, and light would follow spirals instead of straight lines. Time would slow almost to stillness. Each second above would stretch to eternity below. And yet, in this timeless place, the star would still spin steady and sure, keeping rhythm in the dark. To imagine a pulsar is to glimpse balance in its purest form, collapse and rotation, destruction and precision, power and harmony. Even as they fade, these stars send their signals across the galaxy, carrying knowledge of physics that words can barely express. They are proof that even in death, the universe continues to create. From what once was chaos, it crafts rhythm. From what once was flame, it crafts order. In their spinning, we hear the echo of the cosmos learning to count time. The sound of a pulsar, when converted to audible frequencies, is hypnotic. A steady, ticking calm, yet endless. Listening to it feels like hearing the heart of creation itself. Each beat reminds us that somewhere far away, a city-sized star continues to turn in perfect silence. Its clockwork rhythm has endured since long before Earth formed, and will continue long after our world is gone. They are not just remnants of what once was. They are promises of what endures the steady breath of a living universe. And as we leave these cosmic clocks behind, the rhythm deepens once more. Beyond them lie places where gravity becomes absolute, where not even light can return. There, the fabric of time bends until it breaks, and the universe whispers through silence. That is where we now travel into the heart of the infinite, pull the realm of black holes. And beyond the pulse of dying stars, we find gravity's final expression, the dark horizons where light itself is caught and time slows to a whisper. In the next chapter, we descend into that stillness where light cannot escape. There are regions in the universe where light itself can no longer flee. These are not places of fire or storm, but of stillness, so deep, so absolute, that even the fastest thing in existence is trapped. We call them black holes, and they are the final expressions of gravity's power. They begin as massive stars burning for millions of years, before collapsing inward under their own immense weight. When nuclear fuel runs out, and fusion can no longer resist gravity, the star folds in upon itself until nothing remains but a singularity, a point where matter becomes infinite density and time begins to curve beyond recognition. Surrounding that singularity lies the event horizon, a boundary with no surface, no edge, only a threshold. It is the point of no return, where escape velocity equals the speed of light. Once anything crosses it, light dust, thought, or dream, it can never come back. Yet from the outside we never see an object pass through. As it nears, the horizon time itself stretches, movements. Slow light reddens, and the final moment appears to freeze forever. What falls into a black hole is lost to sight, but not to the fabric of the universe. Its mass, its energy, its information, all become part of the gravitational presence that remains. In a strange way, a black hole is both a grave and a memory. It keeps the story of what it has consumed, encoded in its spin, its charge, and its mass. These three qualities, nothing more, nothing less, are all that can be known of what lies within. This is called the no-hair theorem of black holes, that they erase all other details, leaving only these three whispers behind. And yet physicists have begun to wonder if information, the essence of everything that ever was, might still survive, not destroyed, but imprinted on the surface of the horizon, waiting to be read in some future we cannot yet reach. If we could stand near one, we would not see a hole at all, but a sphere of darkness, framed by radiant fire. Around many black holes, swirling disks of gas and dust form accretion disks heated to millions of degrees. As they spiral inward, they glow in X-rays and ultraviolet light, brighter than any single star. Jets of plasma shoot outward from the poles at nearly the speed of light, powered by magnetic fields and rotation. These jets stretch for thousands of light years, shaping the evolution of galaxies themselves. The black hole, though invisible, becomes a cosmic engine, silent yet creative, a sculptor of the space around it. The first direct image of a black hole's shadow, captured by the Event Horizon Telescope, revealed this paradox in haunting clarity. A glowing ring of gas encircling a circular void, brighter on one side, due to light bending around the spinning mass. The darkness within is not a solid object, but the absence of returning light. What we see is gravity drawing a line between being and beyond the edge of visibility, the limit of sight itself. In that image lies both mystery and serenity, the calm face of cosmic power, suspended in infinite patience. Inside the event horizon, space and time exchange roles. Moving forward in time becomes as inevitable as falling inward. No force can resist it. No motion can turn aside. The future for anything within is the singularity, the place where our understanding ends. And yet, from the viewpoint of physics, the singularity is not necessarily a true end. It may be a doorway, a boundary of comprehension, a place where the known laws of reality dissolve into quantum possibility. Some theories suggest that what disappears into a black hole might emerge elsewhere, perhaps in a new universe, perhaps as part of the next cosmic breath. For all their reputation as destroyers, black holes are also keepers of balance. Their gravity anchors galaxies, including our own. At the center of the Milky Way, a supermassive black hole, Sagittarius A times, holds millions of suns worth of mass in a region smaller than our solar system. Around it, stars orbit at unimaginable speeds, tracing elliptical paths that reveal the dark center's weight. Without that gravitational heart, our galaxy would lose its coherence. Its elegant spiral would unravel, and the stars would drift apart like leaves on wind. In smaller forms, black holes are born from the deaths of massive stars. In their youth, they feed on the matter of companions, creating brilliant bursts of X-rays before settling into silence. Some drift quietly through the galaxy, invisible, except for the slight bending of light behind them, micro-lensing events that betray their presence for only a moment. Others merge with their kin, colliding in bursts so powerful that they shake space-time itself. These collisions send gravitational waves, rippling outward waves that we can now detect on Earth. Each one a faint echo of cosmic fusion, billions of years old. The discovery of those waves proved that space-time is not static, but alive, vibrating under the weight of movement and energy. When two black holes merge, their dance converts enormous mass into pure motion, the very fabric of existence shivering in response. The detectors that recorded this phenomenon deep in silence and isolation heard what Einstein only imagined: the ringing of the universe like a great, low bell. In that tone, faint yet infinite, was the sound of creation's pulse, gravity singing to itself in the dark. And yet, even black holes are not forever. Over unimaginable time, they too fade. Through a process known as Hawking radiation, they emit faint particles, a slow leakage of quantum energy from the vacuum near the horizon. This radiation is incredibly weak, but constant. Over trillions upon trillions of years, even the largest black holes will evaporate their horizons, shrinking their darkness, dissolving into light. When the last one fades, the universe will enter its quietest age, a night, without gravity's fires, a peace beyond measure. It is a strange comfort to know that even the greatest forces must eventually rest. Nothing escapes the rhythm of balance. Not stars, not galaxies, not even gravity's strongest embrace. Everything that exists, from the smallest particle to the largest void, shares the same destiny of transformation. To see the truth is to understand that endings are never truly ends, but continuations in another form. The universe recycles even its shadows. Black holes remind us that mystery is not chaos, but order beyond comprehension. They do not threaten, they reveal. They show us that knowledge has horizons, that every boundary of science hides a deeper layer waiting to be understood. In their darkness lies a reflection of our own curiosity, the desire to look, to ask, to reach beyond what can be seen, to stand beneath the stars and feel that there is more, always more, waiting in the silence. And so we drift onward, leaving these cosmic abysses behind. They remain at the centers of galaxies, silent anchors of motion, endlessly patient in their watch. Around them, stars continue to orbit, light continues to bend, and the universe continues to expand. Even in their darkness, creation persists. For as much as black holes consume, they also connect, uniting matter, energy, and time in a single eternal symmetry. As we emerge from their shadow, the universe widens once more. The spiral arms of galaxies extend like ribbons of light, turning gently within the vastness. Stars orbit in graceful synchrony, drawn by invisible bonds, moving not toward chaos but harmony. And so, as gravity's final masterpiece fades from view, we begin to see the greater dance, the movement of the cosmos itself, slow and eternal, spinning quietly through time. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. High above the quiet horizon of night, our galaxy turns. The Milky Way, a soft river of silver light, drifts across the darkness like a memory in motion. It looks still to our eyes, yet every star, every world, every cloud of gas within it is moving. We are passengers on a great spiral, circling the galactic heart with elegant patience. Every 230 million years, our solar system completes a single orbit, one slow revolution through the arms of this luminous sea. If you could see our path from afar, you would not see a flat circle, but a gentle helix, a spiraling wave that moves upward and downward as it winds around the galaxy. The Sun and all its planets rise and fall through the thin galactic plane every 30 million years or so, bobbing like a leaf carried by an invisible tide. This motion is part of a rhythm that has lasted since the beginning. Gravity guiding light, and matter through a dance too vast for any single lifetime to measure. Our home, the Milky Way, is a barred spiral galaxy, a disk about 100,000 light-years across, with sweeping arms that twist outward from a dense central bar of stars. In that core lies Sagittarius A times the supermassive black hole, whose gravity anchors the entire structure. Around it, hundreds of billions of stars orbit in a pattern, both chaotic and orderly, like fireflies moving through unseen wind. Between those stars, dark lanes of dust and gas form cosmic rivers, places where new suns are born and the galaxy renews itself. We are far from the center, about 27,000 light-years away, near the quiet edge of a spiral arm called Orion's Spur. Here, our solar system drifts gently between two larger arms, Perseus and Sagittarius, regions rich with nebulae clusters and ancient remnants of exploded stars. The Milky Way's light looks smooth from a distance, but up close, it is a tapestry of creation and decay. Every glimmer you see is a sun, and each one has its own orbit, its own motion, its own story. Despite the grand scale, the galaxy moves with perfect balance. The gravitational pull of billions of stars, dark matter, and cosmic gas keeps everything in a kind of silent harmony. Nothing collides by chance. Every orbit is part of a pattern. Even our nearest neighbors, the Magellanic Clouds, two small, irregular galaxies, move in rhythm around us, their gas trails forming faint bridges that connect us through space. Gravity is the music, and every star is a dancer following its silent tempo. Sometimes, galaxies meet and merge, and when they do, the dance becomes even more beautiful. The stars rarely collide. Space is too vast, but their orbits weave together, forming tidal streams and glowing arcs that shimmer like veils across the dark. In 4 billion years, the Milky Way will merge with the Andromeda Galaxy, creating a new, larger system, a cosmic waltz that will last billions of years. To those who may still exist, then the night sky will transform, filled with graceful curves of stars drawn together in quiet inevitability. Though that future seems distant beyond imagination, it is already written in the pull of gravity. Andromeda is approaching at about 250 miles per second. Its faint haze, visible even now, as a small, elongated blur in the constellation of the same name. Each night it comes closer, though the distance between us is still over 2 million light-years. When the two galaxies finally meet, their stars will blend into a single, elliptical glow. From the perspective of time itself, it will be not destruction but reunion, two rivers joining in one sea. As our sun and its planets follow their spiral path, they carry with them traces of this grand choreography. The solar system moves not in isolation, but as part of a cluster of nearby stars, the local group, a family that includes the Milky Way Andromeda and dozens of smaller companions. Together, this family drifts through a still greater structure, the Virgo supercluster, which itself is just one thread of the cosmic web. Every motion we make, every turn of our world, participates in a pattern that stretches beyond comprehension. When you stand beneath a clear sky, you can feel that motion, though you may not sense it directly. The faint sweep of the Milky Way above you is not fixed, but alive, flowing, drifting a spiral, turning through the ages. The light that reaches your eyes tonight began its journey before humans existed, before continents formed their current shapes. You are seeing into deep time, watching the galaxy as it was when the first forests grew on Earth. Every shimmer, every silver cloud above you is light, still traveling, still carrying the memory of the ancient dance. Astronomers have mapped this motion in exquisite detail. Using radio telescopes and infrared surveys, they trace how gas moves within the spiral arms, how stars cluster and drift, how dark matter holds the disk together. The spiral arms themselves are not fixed objects, but waves, density patterns, that move through the galactic disk, gathering and releasing matter as they go. Stars are born within them, shine for a time, then move away as the pattern continues forward. The arms are the galaxy's heartbeat, slow, and eternal. Our sun is just one of those travelers orbiting the center at nearly 500,000 miles per hour. Yet we do not feel the motion. Gravity holds us gently, and the distances are too immense to sense. The Earth turns, the Moon orbits, the Sun moves, all within motions far greater still. And so our days, our seasons, our lives unfold inside this cosmic rhythm, part of a harmony so vast that even silence becomes a kind of song. Over the eons, the Milky Way has shaped and been shaped by its neighbors. Streams of stars stretch from its edges, remnants of smaller galaxies consumed long ago. Clouds of hydrogen drift along its outskirts, faintly glowing in radio light, feeding new generations of stars. In its halo, ancient clusters spin like frozen jewels, each containing some of the oldest stars ever known. They are the elders of the galaxy keeping watch as the younger arms swirl below. And through all this, the sun continues its slow voyage, carrying our small blue world in gentle orbit. The galaxy turns, and we turn with it, unaware most days that we are part of something so grand. Yet every sunrise, every nightfall, is proof that we are in motion. The Earth spinning the solar system, spiraling the galaxy drifting. Time and gravity weave together, and we, tiny and brief, are carried within their design. If you could look down from beyond the galaxy's edge, you would see an immense spiral, radiant and calm. Its arms curve outward, like a flower opening in slow motion, glowing with billions of suns. Within it, the traces of dust and gas form delicate filaments that glimmer faintly, like the breath of something living. From such a view, you would understand that galaxies are not static things. They are symphonies of motion composed over billions of years, still playing, still expanding, still unfolding. And somewhere within one of those spiraling arms, a small star continues to move, in perfect rhythm, carrying its planets through the deep night. Around that star, a single world breathes, listens and wonders about its place in all of this. It looks up and gives the galaxy a name, not knowing that the galaxy too holds it close, a dancer in its eternal movement. And as the Milky Way glides through space surrounded by companions and tethered to the cosmic web, it reminds us that motion itself is creation. The universe is not a static painting, but a flowing river, a rhythm of orbits and waves, endlessly renewing itself. Our galaxy is one verse in that cosmic song, vast, luminous, and still growing. And now, as we drift beyond the spiral arms, we approach the edge of sight. Beyond the glow of the Milky Way lies the uncharted dark, the limits of what we can observe. There, the universe expands faster than light can return, and the horizon of knowledge stretches away into silence. It is here that we pause and look outward once more, toward the farthest boundaries of being. Beyond our galaxy's graceful motion lies a horizon that is not truly an edge, a boundary made of distance, time, and the speed of light itself. In the next chapter, we journey outward to that limit to understand the ever-expanding frontier of existence, edges that are not edges. There is a limit to what we can see, but not to what exists. The universe, though infinite in potential, has an observable edge, a soft horizon drawn not by walls but by time. Beyond that faint line, light has not yet reached us. The cosmos is still unfolding there quietly beyond the reach of our sight. This is not a border, but a veil of distance, a reminder that the speed of light and the age of the universe together form the boundary of our knowing. When we look deep into the sky, we are looking backward through billions of years. The farther our gaze, the younger the universe we see. The most distant light, visible to our instruments, began its journey when matter first condensed, when galaxies were still forming and stars were just beginning to ignite. That light, stretched by cosmic expansion, reaches us today as a whisper from the beginning, ancient, red-shifted, softened by the growth of space itself. It forms a kind of horizon called the observable universe, about 93 billion light-years across. Beyond it, there is more, much more, but it is forever hidden from us. The space beyond our horizon recedes, faster than light can travel, not because it breaks any law of physics, but because the fabric of space itself expands. Imagine ink dots on a balloon. As it inflates, the dots move apart, not because they travel over the surface, but because the surface stretches beneath them. So it is with galaxies. Each one drifts away not through space, but with space. Expansion is not motion. It is the quiet widening of everything. Even here, on our side of the horizon, galaxies far away move faster than any ship could chase. The farther they are, the greater the redshift, until their light is stretched into invisibility. To look in their direction is to look at something that no longer exists as it once was. Their light shows us their youth, while they themselves have continued to age, expand, and perhaps even fade into the unseen. The universe we observe is a layered mosaic of times, every distance, a different moment, every faint shimmer, a message from the past. This is why the cosmos feels infinite, because every glance outward is also a journey backward. The night sky is not a flat window, but a deep well of history. When you look at the faint glow of a distant galaxy, you are witnessing an echo of an age when the universe was only a few 100 million years old. You are looking at the first breaths of cosmic structure, at light that began its journey. Before Earth, before oceans, before memory, the edge of the observable universe is defined not by place, but by time itself. It is a horizon made of history, not matter. What lies beyond is forever beyond communication, because the expansion of space carries those regions away faster than even light can chase. To reach them would require traveling not through distance, but through time itself. And even then, the universe's acceleration ensures the goal keeps receding. In this way, the cosmos teaches humility, that knowing has limits, and yet wonder has none. The expansion of the universe is not uniform everywhere. It is driven by a mysterious pressure known as dark energy, an unseen force that acts like a cosmic wind, pushing galaxies apart. Unlike gravity, which pulls things together, dark energy works in silence to stretch the fabric of space-time itself. No one knows what it truly is. Perhaps a property of the vacuum, perhaps a field that pervades all existence. But its effects are clear. The universe's rate of expansion is increasing. Space is accelerating into openness. This discovery, made through careful observation of distant supernovae and galaxies, changed our understanding of everything. It revealed that the cosmos is not slowing down, but speeding up, that the more it grows, the faster it expands. It means that in the far future, galaxies beyond our local group will drift beyond sight, their light stretched until it vanishes entirely. The stars will fade, the sky will darken, and the visible universe will shrink until only our own cluster remains adrift in a dark, silent sea. Yet, this is not a bleak destiny. It is a continuation of the same quiet rhythm we have followed since the beginning: expansion, balance, and rest. Even as space grows, it also gives rise to new stars, new worlds, and new eyes to see them. The universe does not end at its horizon. It continues in directions we can only imagine. Each boundary we reach reveals not confinement, but invitation, a call to wander further. Some scientists believe there may be other regions beyond our own separate universes, each with their own laws, their own constants, their own light. If true, then what we call the universe may be only one bubble in a vast cosmic foam, each bubble expanding, colliding, or drifting apart in an endless sea of possibility. We cannot see them, but mathematics and theory whisper of their existence. The multiverse, if it is real, would mean that creation has no true edge at all, only layers of infinity, each containing its own story. But even if ours is the only universe, it is still immeasurable in its beauty. The cosmic horizon, far from being a limit, becomes a mirror, showing us that there is always more to discover, that the unknown is not emptiness, but potential. The edge of sight is the beginning of imagination. The further we look, the more we understand how small our place is and how miraculous it is that we can look at all. If we could step outside this horizon, what would we find? Perhaps more galaxies, more webs of dark matter, more light forever traveling outward, perhaps something entirely new, something that defies even our most daring thought. But perhaps we would find nothing, not emptiness, but the stillness of everything that has already been waiting patiently beyond reach. The truth is not something we can hold. It is something we approach with every act of observation. The universe expands, and so do we. Our curiosity stretches the boundaries of the known, just as galaxies drift beyond the limits of sight. The edge is not a wall, but a reminder that discovery and wonder are twin forces, forever moving outward. Each new horizon opens into another, and in that infinite unfolding lies the beauty of existence itself. And so, as the cosmos continues its gentle acceleration, we find peace in knowing that it will never truly end. There will always be another distance, another mystery, another quiet question to chase. The horizon moves, and we move with it, carried by the same expansion that began in the first light of creation. The edge of the universe is not a place of ending, but of continuation. It is where light fades, not because it dies, but because space itself stretches its voice too thin for us to hear. Yet even silence carries meaning. Beyond the reach of our instruments, the universe continues to hum softly, endlessly, beautifully. And as we turn from that farthest horizon back toward the home of stars and dust and life, we carry with us the understanding that everything everywhere is connected. From the smallest atom to the largest void, all belong to the same great breath, expanding, pausing, and flowing again. And now, as we leave the edge behind, we drift toward the quiet places between galaxies where cold and stillness rule, and where the universe prepares its long, serene exhale. Beyond the expanding horizon lies stillness, the cold, silent regions where galaxies grow faint and light becomes rare. In the next chapter, we travel into those quiet realms, the cold and silent places. Between the galaxies, there are stretches of space so vast and empty that even light grows thin. These are the cosmic voids, immense regions where there are no stars, no planets, no warmth of radiation, beyond the faintest whisper of the cosmic background. In these dark expanses, temperature sinks toward absolute zero, about 459 degrees below zero Fahrenheit. It is a stillness beyond silence, a calm that has lasted for billions of years. Here, matter is rare, and what exists drifts slowly untouched by light or time. The space between galaxies is not truly empty. It holds atoms and particles, faint traces of hydrogen gas, cosmic dust, and ghostly neutrinos left from the earliest moments after the Big Bang. These are the remnants of creation's first breath, spread so thin that in a cubic mile of intergalactic space, there might be only a handful of atoms, and yet they still hum faintly with energy. Even emptiness glows bathed in the cold echo of the cosmic microwave background. A radiation that fills all of space, the afterglow of the universe's birth. This radiation, though invisible to our eyes, can be measured with sensitive instruments. It has cooled over billions of years to just 7 kelvins, a fraction above absolute zero. It is the oldest light, still traveling, a relic from a time when the universe was only a few 100,000 years old. Every photon of that light has been stretched by expansion until its wavelength is longer than the tallest mountains on Earth. What we feel in these cold regions is not absence, but endurance light that refuses to fade, energy that persists even when all else falls to silence. Imagine yourself adrift in such a place. You would see no stars, no constellations, no horizon. Only the faint, uniform glow of the background, filling the darkness like the soft breath of memory. Around you, space would appear utterly still, yet the universe would continue to expand. Galaxies far away would drift beyond your sight, their light redshifting into invisibility. Time would feel slower, though it would flow as ever quietly, evenly patient. You would be surrounded by nothing, and yet in that nothing, you would be held by everything. These vast cosmic voids make up most of the universe's volume. The glowing galaxies, we see the clusters and filaments that fill our telescopes, form only the framework of the cosmos, the bright threads in an otherwise dark web. Between those threads lies a sea of emptiness, hundreds of millions of light years across. And yet the voids are not static. Over time, gravity continues to pull matter toward the filaments, making the emptiness deeper, the cold sharper. Each passing eon stretches them wider until they seem almost eternal. The cold of these voids is more than physical. It is spiritual in its quietness. There is no movement, no sound, only the eternal hum of existence itself. Scientists studying these regions find that the few particles within them can remain untouched for billions of years, never colliding, never disturbed. The universe is vast, but in these spaces, it feels infinite, a calm so complete that it surpasses understanding. This is the universe at rest, the pause between heartbeats, the still breath between creation and renewal. Yet even in this profound silence, there are faint threads of connection. Cosmic rays, high-energy particles, born from the death of stars, still pass through, traveling across unimaginable distances. Gravitational waves ripple softly, imperceptible but real, the subtle tremors of the cosmos breathing. Even the voids participate in the universe's balance, providing space for expansion, allowing galaxies to evolve and stars to form along the edges of their emptiness. In their cold solitude, they preserve the equilibrium of existence. If we could look upon the universe from beyond, the voids would not appear as blank darkness, but as part of the same intricate pattern that forms galaxies and clusters. Their emptiness gives shape to the luminous web, just as silence gives meaning to music. Without the dark spaces, the glowing filaments would lose their contrast. Without the quiet, there could be no song. The cold and the light together create harmony, each defining the other, each necessary for beauty to exist. This harmony extends to every scale. Inside galaxies, space is full of warmth and light, but between them, there is this soft, vast cold. Inside atoms, energy dances in constant motion, but beyond them, particles drift in near stillness. Everywhere we look, the universe balances movement with pause, brightness with shadow, heat with chill. It is this balance that makes creation enduring, not the flame, but the space it fills. As the universe continues to expand, these cold regions will grow larger still. Galaxies will drift farther apart. Stars will fade, and interstellar gas will thin, until even light rarely finds a place to rest. One day, billions of years from now, the cosmic background will cool further its temperature, dropping closer to absolute zero. In that distant future, the universe will be dark to the eye, but not dead. Even then, energy will hum faintly within the vacuum, and quantum particles will still flicker in and out of existence. Proof that nothingness is never truly empty. This vision of the far future might seem lonely, yet there is serenity in it, a peace that only time itself can create. The same stillness that fills the cosmic voids exists in the spaces between our thoughts, in the quiet moments when we stop to listen. The cold between galaxies and the silence between heartbeats are made of the same essence: rest. The universe is not rushing toward an end, but gliding toward balance. And so the cold and silent places are not to be feared but understood. They are the universe's resting breath, the pause that allows creation to continue. Just as night follows day to restore balance, the cosmic voids remind us that stillness is not emptiness, but completion. The stars burn because the darkness allows them to. The galaxies dance because the void gives them room to move. When you gaze into the night sky and see the vast black between stars, you are looking at this same serenity. That darkness is not absence, but presence. The presence of space itself, patient and ancient, waiting for light to pass again. It is the canvas upon which the universe paints its story. Without it, there would be no contrast, no shape, no wonder. The cold, silent regions give meaning to everything that glows, and so we drift here for a moment longer, in thought and quiet reflection, letting the vastness surround us. The universe breathes in darkness and exhales in light, and we too are part of that rhythm. Our hearts beat with the same patience, our lives unfold within the same balance. In the stillness, we find belonging, a quiet truth, written across the stars and the spaces between them. And as we move on from this silence, we approach the final act of the universe's long story. The slow fading of light, the gentle dimming of motion, and the peaceful transformation of all things into quiet equilibrium. And beyond even this stillness, time stretches into eternity, a long, tranquil drift toward balance. In the next and final chapter, we follow the universe into its softest moment of all, the long goodbye. The universe will not end in fire, but in silence, not with a bang, but with a breath so slow it can scarcely be felt. Over uncountable eons, the galaxies will drift apart, their light fading, their stars cooling into embers. Time itself will stretch thin, like light passing through glass. The energy that once burned so fiercely will soften, and what remains will settle into stillness. This is not destruction, but rest, the long goodbye, the final chapter in the story of everything. Even now that future is unfolding, though we are too young to notice, the stars that fill our skies are still bright and restless, but their fuel is finite. Hydrogen burns to helium, helium to heavier elements, and eventually even fusion must end. In the far future, the great blue stars will die first, their brief lives ending in supernovae that scatter their riches into the void. The smaller, steadier suns will linger longer, burning gently for trillions of years, before dimming into quiet embers, white dwarfs, glowing faintly like the last coals of a dying fire. Those embers will cool slowly and patiently until their light fades completely. They will become black dwarfs, cold remnants that no longer shine but still retain the memory of heat. Around them, planets may continue to orbit in silence, frozen, and still their histories written in dust. Gravity will persist, though its companions' warmth and light will have long gone. The universe, once brilliant with starlight, will then become a vast field of shadows, sprinkled with the faintest afterglow of a time when creation burned. By then, galaxies will have drifted so far apart that no new light can travel between them. The cosmic expansion, driven by dark energy, will have carried them beyond each other's horizons. Each cluster will become an island, a solitary refuge, adrift in infinite night. Future observers, if any remain, will see only the stars of their local group. The rest of the cosmos will have vanished beyond sight, not because it ended, but because its light can no longer reach them. The night sky will shrink until it becomes a small enclosed world. Stars will still form for a time. Gas will collapse into new suns along the last filaments of matter. But with each generation, less fuel remains. Fewer stars will be born. The great spiral arms of galaxies will fade into loose clouds and eventually into individual stars, traveling alone through the dark. The Milky Way, merged with Andromeda long before, will settle into a quiet elliptical glow. Its remaining stars will shine like scattered candles in a cathedral after all voices have fallen silent. As time continues, the balance of the universe will shift once again. Black holes, the final custodians of gravity, will dominate the dark. They will continue to merge and consume what remains, pulling in stars, gas, and dust, until only their immense shadows remain. Each merger will send out gravitational ripples, the last songs of movement traveling through the dark. Even these, in time, will fade into silence as black holes slowly evaporate through Hawking radiation, their energy leaking back into the cosmos as soft, invisible warmth. It is a strange comfort that even black holes are not eternal. Over unimaginable spans of time, 10 to the 100th power years, perhaps more, they too will vanish, leaving only faint streams of energy behind. The universe will then consist of a thin sea of particles and radiation, evenly distributed and infinitely calm. The temperature will approach absolute zero, motion will slow, interactions will cease, and in that stillness, the universe will find peace, its long, patient breath finally released. This far future is sometimes called the heat death, a phrase that sounds final, but perhaps should not. For heat death does not mean destruction. It means equilibrium. It is the point at which energy is perfectly balanced, where nothing more can change because all has already become part of the same stillness. It is not the end of existence, but the end of contrast, the fading of difference between light and dark, motion and rest, life and sleep. It is the cosmos at perfect rest. And yet, even in that stillness, quantum mechanics whispers of possibility. Tiny fluctuations may continue to ripple through the vacuum, ephemeral particles flickering into and out of being. Perhaps, given enough time, one of those fluctuations could spark something new. A sudden, spontaneous birth of energy in space. Another Big Bang, blooming in the quiet sea. In this way, the universe might never truly end, but instead renew itself again and again, each cycle born from the stillness of the last. Such an idea, that even silence can sing again, feels deeply human. It reminds us that endings are not always final, and that from stillness creation may rise once more. Just as a seed sleeps in the dark before awakening to light, so too might the universe rest before breathing again. The death of one age could become the dawn of another, as time, space, and energy find new shapes to wear. The long goodbye may be only the long pause between verses in an infinite song. From where we stand now, though the end is not a thing to fear, we live in the universe's springtime, when stars still burn and galaxies still shine, and life can wonder at it all. Every sunrise, every falling leaf, every whisper of wind through trees is a part of this fleeting brightness. We are made of stardust, shaped by fusion, held together by gravity, the universe knowing itself for a brief, luminous moment. To live now is to exist in the middle of the story when light still dances and the song still plays. In that awareness lies peace. Knowing that everything changes, that even stars fade, makes each moment more precious. The universe is not eternal in form, but in process. It transforms, renews, and flows endlessly. And we, being part of it, share in that flow. When our small lights dim, we too return to the pattern. Our atoms drifting outward, joining the cosmic breath, carried again into new stars, new worlds, new eyes that will look back into the dark and wonder. And so the universe continues its long, slow farewell. Not a tragedy, but a transformation. Light turns to memory, memory to silence, silence to possibility. Every stage, every phase, part of a single endless rhythm. The cosmos breathes in expansion and exhales in stillness, its pulse vast and patient beyond imagining. There is beauty, even in the fading, for in that soft dimming lies truth that creation at every scale is both finite and infinite at once. Close your eyes for a moment and picture that far future, not empty, but quiet. Not gone, but resting. The stars are memories, the galaxies whispers, the space between them deep and gentle. All is calm, all is balanced, all is peace. The universe has completed its long arc, returning to the silence from which it began. And in that silence, perhaps a new breath gathers unseen, waiting inevitable. And now, as the universe settles once more into quiet balance, may your thoughts drift gently among the stars. The story of everything is also the story of rest of light, returning to stillness of time, folding softly into forever. You are part of that story, brief, bright, and beautiful. Sleep well beneath the endless sky, for even in darkness, the universe remembers you. And now, as the stars grow dim and the rhythm of the cosmos slows, we return to silence. The galaxies still turn, their light still travels, and the universe continues its patient breath, the same breath that moves gently through you. Wherever you're listening from tonight, a small apartment, a forest cabin, a quiet stretch of desert sky, know that you are part of something immeasurable, something still unfolding. Let the calm settle deeper now, like starlight fading behind your eyes. The story of the universe never truly ends. It only changes form, just as dreams become dawn. If this quiet journey brought you peace, stay a little longer. There are more worlds waiting to unfold here on Science Dreams channel. Subscribe, breathe, and drift with us again, soon into the silence where science becomes poetry and the universe dreams in you.